Okay, in this one, we're going to work on a few more conversions from binary to decimal. One thing that we do sometimes when we've got a binary number is we put a little subscript 2 next to it to denote that it is a binary number and this isn't a decimal number. So what we want to do is we want to find out what this is equal to as a base 10 number. So we can use a little subscript 10 for that. So for all of these problems, what we need to do is we have to use our powers table for this. So the objective is to take each of the place values and then add them together whenever we've got a 1. So here we've got 1, 2. We don't have any, sorry, that is completely wrong. That's a 1. We don't have any 2s, so there's a 0 over the 2. A 4, we've got 1, 4. The 0 here represents the 8's position. We don't have any of those. We have a 16 for this. The 1 here is referring to the 16's position. And then we have 164. So then all you need to do is you need to add these values together. So plus, plus, plus equals. So what we get here is 80 plus 4 plus 1 is going to be 85 altogether. So 85. So the answer here is 1010101 in binary is equal to 85 as a base 10 number. Let's do a few more here. Move this up. Let's try 1011100. Now, we don't have anything for the 1's position, so that's nothing, nothing. And then this one here is going to represent the 4s. So we've got 1, 4, 1, 8, no 16s, and a 32. So if we're putting this together, this is a base 2 number. I want to find out what it is in decimal. So 32 plus 8 is 4, plus 4 is going to be equal to 44 as a base 10 number. We'll do one more example. This one's going to be a really long one, and I'll show you a little trick here. So here we've got 1, 1, 1, 1, 1, 1. So we've got a whole bunch of additions that we've got to get for this one. So this is the 1's place, the 2's place, the 4's place, the 8's place, the 16's place, and the 32's place. So then what we've got to do is we've got to add all these values together. So plus, 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 plus. I like making groups of 10. That's how my decimal mind works. So 32 plus 8 is going to give me 40. 16 plus 4 is going to give me 20. So I've got 60 there. And then plus 3 is going to be 63. So this is a base 2 number, is going to give me 63 as a base 10. So here's a trick that it's still a good idea to figure out the conversions by this, because this is something that you would need to do to understand how the conversions work. But if we wanted to check our answer, like maybe we're not super confident that that's a 63, but if you take a look at this, the next number up here on the powers table is a 64. So if I was representing 64, that would be like 1 with 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6. So this number is 64. And if you remember from counting, if you had this number and you added 1 to it, this would be a 0, 0, 0, 0, 0, 0, and it would push a 1 here. So one number higher than 63 would be 64. So that's maybe a little bit of a shortcut when you've got a whole bunch of 1s, is you can do it subtractively.